So we'll see what was Faraday's experiment. Okay, see, Faraday and Henry, both of them together, what they did was they were trying to you can say induce electric current by magnetic field, right? So see, the experimental setup goes like this. So what they have is they have one coil. See, you have a coil, that's the primary coil. Primary is basically connected to the source, some voltage source. They have a key. Okay, and then there is one more coil. See, the secondary coil. The secondary coil is connected to the galvanometer, correct? So this is the experimental setup. They have two coils, primary, secondary. Primary is connected to the source, secondary is connected to the galvanometer. All right. Now they switched on the key. Okay, when they connected them, when the circuit was complete, what was happening was the magnetic field in the primary coil was increasing, correct? So what happened was when they saw the galvanometer showed a deflection. All right. So that means in the secondary circuit or the secondary coil, there has to be current, right? Okay. So then they switched off the power in the primary. Then the galvanometer showed the same deflection but in the opposite direction. All right. So in the initially, whatever the direction it was showing, once the current was switched off, it was showing in the opposite direction. So they were like, okay, why was it happening? Then they came to the conclusion that in the primary, the magnetic field keeps on increasing once the current starts flowing. So those magnetic field lines were coming in contact with the secondary coil. Because of that, current was being induced. Okay, this was the first experiment. Now, just by one experiment, we can't conclude that, okay, this is the result. So what they did was, just to make sure that the current was induced by magnetic field, they did one more experiment. Okay, see, in the second experiment, what they did was the coil was there. See, as you can see, the experimental setup is coil is connected to the galvanometer. Then they have a bar magnet. Okay, they have a bar magnet. So the bar magnet was introduced inside the coil. Then galvanometer showed a deflection. Then the magnet was removed. Again, the galvanometer showed deflection, but in the opposite direction. All right. So magnet, it's a magnet. Come on, magnetic field will be there. So then they confirmed that because of the change in magnetic field, a current was being induced. Okay. So fine. Now, is it always true that the coil has to be stationary and magnet has to move? Is it always true? No. For that, they did third experiment. Okay, in the third experiment, so there was into the plane magnetic field. Okay, and there was a moving coil. So coil could be a rectangular coil also, need not be a circular coil, correct? So they had a rectangular coil. Now they moved the rectangular coil, galvanometer showed deflection. Then they moved the coil in the opposite direction, and then galvanometer showed current deflection in the opposite direction. So using these three experiments, they confirmed that if there is change in magnetic field, then there is induced current. All right. See, in these three experiments, just look at the overview of the experiment. See, in the first experiment, there was varying magnetic field, correct? Because the current was increasing, so magnetic field was increasing. In the second experiment also, you move the magnet inside the coil, you take it out. So there was change in magnetic field, correct? Linking with the coil. And in the third experiment, magnetic field was constant, but coil was moving, right? So using these three experiments, they confirm that whenever magnetic field is there, then induced current will be there. Okay. So using these three experiments, Faraday formulated law. Okay. The Faraday's law, what we call. So we'll see in the next video what Faraday stated in his laws.